There are moments when we suddenly understand a complex subject, like a math problem or a grammar rule, and feel a sense of relief and joy. This is similar to the feeling Archimedes must have had when he discovered the principle of buoyancy in his bathtub and ran through the streets shouting, "Eureka!" About 360 years ago, Isaac Newton experienced a similar sense of relief and clarity when he understood the order of the universe, which wasn't as complicated as it seemed. Let's follow the sequence of how Newton unraveled this mystery. The English scientist Isaac Newton was 24 years old when he was resting one evening in an orchard, deep in thought under an apple tree. Newton was already engaged in important research at this young age. During this moment, an apple fell at his feet. This was not an extraordinary event. However, when Newton looked up, he saw the moon, shining brightly like a giant apple in the sky. He began to ponder, why did the apple fall, and why does the moon, which is not attached to anything, not fall? As you know, when an object falls, its speed is initially very slow, but accelerates as it approaches the ground. This speed increases proportionally to the height from which it falls, and the force pulling it down is gravity. Newton wondered why the moon was not affected by gravity and how it remained in orbit around the Earth. Thus, the gravitational force must be influencing it. What was the balance between the gravitational pull keeping the moon in orbit and the force preventing it from falling to Earth? Newton thought it might be the distance. The moon's massive weight was mitigated by the distance, suggesting a connection between this perceived weight and distance. Newton had to conduct complex calculations to discover this link, even developing new mathematical formulas to achieve positive results. The concepts that developed gradually in Newton's mind after the apple's fall in 1666 can be summarized as follows. 1. Objects, whether Earth, an apple, or the moon, attract each other. The heavier they are, the stronger the attraction, and the heavier object attracts the lighter one more. 2. The farther apart they are, the weaker this attraction becomes. There must be a point where distance reduces gravity and centrifugal force maintains that distance. Newton's discovery applied to the entire universe. Everything in the universe, whether on Earth or in the sky, from the smallest objects to planets and stars, attracts each other in direct proportion to their masses and inversely proportional to the square of their distances. All movements in the universe can be calculated using these two concepts: mass, which we often call weight, and distance. The flights of the Lunik and Apollo missions can also be explained by these principles. After Newton, the solar system became a valuable field of study for mathematicians. The discovery of the planet Neptune by the astronomer Verrier is a striking example of this.